Okay, hi everybody. I hope you're doing great today. Sorry I can't be there with you, but don't worry. I'm sure you guys are going to be awesome today, so you might as well take Friday off and have a long weekend, and I'll see you guys on Monday. As you can see, we're going to be in our workbooks today on lesson 16, and we're going to kind of tie everything that we've done in the last 2.5 weeks together. So some of this stuff you're going to be like, yeah, I kind of remember that, so pay close attention. Don't just skip through everything and start right there on the homework. Your homework is just going to be numbers 1 through 4 on page 146 and 147. I'm going to let you skip number 5. Actually, I'll do this. If you'd like to do number 5 for extra credit, I'd be A-okay with that, okay? So we're going to bounce around in lesson 16, so don't feel like I'm skipping stuff or I'm not doing everything, because I will be doing that on purpose. All right? So much so, I'm just going to skip the whole first page and jump right in to the second page, because this talks about, and one of the homework problems and homework questions is about remembering if we have a system, right? Sometimes it can have one solution, sometimes it'll have an infinite number of solutions, sometimes it has no solution. So this is hopefully a little bit of a refresher course for us on if we see a system. So in other words, if I take a look at this system right here, x plus y equals 6, 2x plus 2y equals 12, right? Those two equations kind of look the same, right? And then if you look to the right here in this box, right, it will tell us just that. It says the second equation is double the first one, so they're equivalent equations, right? So in other words, if you were to multiply this equation, let's say we were going to solve this with systems of equations, and we were going to solve this with elimination, we would multiply 2, right, and I would get 2x plus 2y equals 12. Okay, and then I would go to subtract everything, right, just like we always do. And 2x minus 2x is 0x, and 2y minus 2y is 0y, and 12 minus 12 is 0. And so then we're left with one of these statements right here. And because this is a true statement, right, that's how we know this system has an infinite number of solutions. Okay, let's take a look at our next case scenario. Here's two different ones over here. Now we're going to be over here. 5x plus y equals 3, and y equals 4 minus 5x. All right, well, it says if you wrote both equations in slope-intercept form, well, the second equation is already in slope-intercept form. Okay, the first one isn't. If we wrote the first one in slope-intercept form, it would look like this. Y equals negative 5x plus 4. Now we can compare that with the other one. The other one, the first one. If we write that in slope-intercept form, there it is. Y equals negative 5x plus 3. Compare slope and y-intercept. It says these lines have the same slope, right? That is the number, right? Number with x. So negative 5 is their slope, but they have different y-intercepts, right? I have a y-intercept of positive 4, a y-intercept of positive 3. So this system has no solution, right? On a graph, they would have the same slope, they would have different y-intercepts. Parallel lines, by definition, they're never going to intersect. Okay, what about the next one down here? Let's see. If the system of equation has exactly one solution, like the problem on the previous page, there are different ways we can find it, right? And that's what we've been doing for the last week or so, right? We've been working on elimination and substitution. And I'm going to tell you now, it doesn't really matter. You can do whichever you prefer, unless they specifically say, hey, solve this with substitution, right? You can solve it with elimination. You can graph it. It's always going to be the same. Sometimes elimination or substitution is a little bit easier for us to do that. And that's what they've done here. So they've done substitution on this graph on this system that we see right here. So we know that y is this expression. So everywhere I see a y, I replace it with x minus 20. All right, that's how we get this right here. So x plus x minus 20 equals 84. They combine their x's to get 2x. Nothing changes with minus 20 and equals 84. Then they add 20 to both sides, right? Opposite operation. 2x equals 104. We figured out x is equal to 52. Once we know that, we can figure out y, right? Remember, y is x minus 20. So we figured out x was 52, so everywhere I see an x, plug in a 52, and yes, we get y is equal to 32. So that's how they came up with 32, in case you were curious. All right, so that sounds good. All right, let's bebop around. And we're going... Alright, we're going to go right over here to the try it. And this is on page 141. So we're going to work through 8 and 9. Again, if you want to pause the video, if you feel pretty confident, pretty comfortable with substitution, elimination, pause this and try these. Okay, if not, I'm going to do both 8 and 9 over here. Alright, so... Alright, let's work on 8 first. So 8 is y minus 3 equals 2x, and y is equal to 4x minus 2. So I'd say this is a really good candidate for substitution. Okay, here's the value I know, right? One of my equations is already solved for y. That's step 1. So everywhere I see a y right here, I'm going to replace it with 4x minus 2. So this is going to look like 4x minus 2. And then the rest of this stays exactly the same, right? Minus 3 equals 2x. I need to solve this equation now. First thing first, let's go ahead and combine these terms here. And let's go ahead and subtract 4x from the left and the right side. Cancels out. Negative 5 equals, be careful with your signs, negative 2x. Now you divide by negative 2, divide by negative 2. X equals 2.5. So we're halfway done. I know that x is the same as the number 2.5. So now what I can do, I'm going to go back and I will use this equation here. Y equals 4x minus 2. Everywhere I see an x, I now know that that is the same as 2.5. So 4 times x, or in this case now 4 times 2.5. And then we just need to subtract 2. So that's not a very good 2.5. There you go. So 4 times 2.5, I think that's just 10. 10 minus 2 is just 8. So there's your 2 answers. So my answers for number 8, if you'd like to write them like an ordered pair, are 2.5 and 8. Okay, number 9, I'm going to solve over here in this area. All right, number 9. Again, if you want to try this one on your own, just pause the video. And go ahead and do that. So here's your expression 1.4x plus 2. I know that is equal to y. So everywhere I see a y in the second equation, we are going to substitute 1.4x plus 2 in its place. All right, so 1.4x plus 2. All right, again, leave the rest of this just like it is. Minus 3.4x equals negative 2. Let's combine our x's. Watch your signs. 1.4 minus 3.4x. That's negative 2. Didn't do anything with plus 2 equals negative 2. Okay. We're going to move this 2 over to the other side. So subtract 2. Subtract 2. All right, it cancels out here. Negative 2x equals negative 4. Divide by your coefficient of negative 2. You get x is equal to 2. You can take either equation that you would like to. All right, I would say the first one is the one that I will choose. So this is y equals 1.4x plus 2. Everywhere you see an x, I know that's the same as the number 2. So 1.4 times 2 plus 2. So 1.4 times 2 is 2.8. 2.8 plus 2, 4.8. Okay, here's your ordered pair. Here's your answer. So x is 2, y is 4.8. Again, you can write that 2, 4.8, just like that. All right. Okay, number 16. So let's use elimination on number 16 to solve this. So I'm going to rewrite these down here where I've got a little bit more room. So I have 2x plus y equals 9. 3x minus y equals 16. If you prefer to have ones in here, you can write those in there. So step 1 in elimination, are x and y on the same side? Yes, they are. Step 2, I need matching coefficients. So your x coefficients are 2 and 3. Your y coefficients are positive 1 and negative 1. So those are close. Is there a number that I could multiply, say, negative 1 by to get it to turn into positive 1? Sure there is. All right, so I will choose to multiply this equation by negative 1. When I do that, it turns into negative 3x plus 1y equals negative 16. Okay. Let's go ahead. All right, you can forget that this equation is here now. And now we're going to subtract. Be careful of double negatives. All right. 2x minus negative 3. So 2 minus negative 3 is really 2 plus 3. So that's going to be 5. 1y minus 1y. Okay, there's good things happen. My y's cancel out. You don't have to put plus 0y, but we certainly could. 9 minus negative 16. Again, a double negative. So that's really 9 plus 16. 25. Okay, so let's get a little bit of room here. So really this looks like 5x equals 25. Solving for x means divide both sides by 5. And we're halfway there. So x is 5. Pick either equation. I can't really read the second one that great anymore, so I'll just use the first one. but I don't think either one of them were that much better than the other. So 2x plus 1y equals 9. Everywhere I see an x now, I can replace it with the number 5. So this is 2 times 5 plus 1y equals 9. That's 10 plus 1y equals 9. Leave y where it is. 10 needs to move over here. So it's a positive 10. Opposite would be negative 10. Right? Or subtract 10. 1y equals negative 1. Okay, there's your two answers. If you want to write them like an ordered pair, 5 comma negative 1. Okay, so that's good. Onward we go. Question number 17. What ordered pair is the solution to y equals x plus 5 and x minus 5y equals negative 9? What ordered pair? Basically, it's asking me to solve that system, figure out what x and y value will work in both of those equations at the same time. So let's go ahead and do that. Y equals x plus 5, and my other equation is x minus 5y equals negative 9. So solve these however you'd like to. I think when we see y equals, like we do in our first equation, I think this says, hey, I might as well just use substitution. So everywhere I see a y in the second equation, we are going to substitute in the value x plus 5. So x minus 5 stays the same. Where I see y, now I write in x plus 5 equals negative 9. Distributive property gets to go. I'm not multiplying by positive 5. I'm really multiplying by this negative 5. So x stays put, so does negative 9. Negative 5 times x is negative 5x. Negative 5 times positive 5, negative 25. We'll combine our x's. X minus, or you can think of that as 1x, minus 5x is negative 4x. Minus 25 equals negative 9. Next step is just to add 25 to both sides. Okay, so we'll do that. And we're left with negative 4x equals 16. So I've run out of room. So negative 4x equals 16. Divide by negative 4. X is equal to negative 4. So there's one of your answers. Go back to your original equations. So I'll just say y equals x plus 5. I now know x is negative 4. So this says y is the same number as negative 4 plus 5. So y is equal to 1. So what ordered pair is a solution to this system right here? Well, we just figured it out. It's the ordered pair negative 4, 1. Right? Remember, in an ordered pair, x value is listed first, y value is listed second. Okay. A couple more questions, and then we'll turn you loose. It says, graph the equations. What is your estimate of the solution of this system? Okay, so think back to when we graph, we need things in slope-intercept form. So this says, y equals mx plus b. Right? This is your slope. Whatever number is here, this is your y-intercept. Slope is best as a fraction, so if you have a whole number, make a fraction. So I'm going to graph this one in blue. So this has a slope of positive 3, or you could think of that as 3 over 1. and this has a y-intercept of -2. Okay, think about what kind of slope is shown by each one of those lines. One on the left is positive slope, the one on the right is negative slope. So go to your y-intercept, that is at -2. Give yourself a dot. And I have a slope of 3/1. So remember, in slope, you go up or down first, and then left or right. So I'm going to go up 3 and over 1, but remember, I want my line to look like this one. So I'm going to go up 1, 2, 3, over 1. Remember, we go up 3 and over 1 from our y-intercept, from -2. Okay. All right. So we can go ahead and... All right, I'd say that line looks just like that. That's not too bad. I'll graph the next one here, just like that. So this is y equals 2x. Now, this one doesn't have a number after it, right? There's nothing after here. You can think of nothing as +0. So this has a slope of -2 and a y-intercept of nothing, 0. Okay, so this one's going to start right here at the origin, and my slope is -2, right? -2/1. I know I want this line to go in that direction. So I can go up 1, 2, and left 1. If you wanted to, you could also go down 2 and to the right 1. Okay, there we go. So it says on here, what's our estimate? Right? We see right here, what is your estimate? No, I meant to underline that. Of the solution. So the estimate is, hey, where do those two lines meet? All right, so they don't meet on a whole number. So maybe they meet, I don't know. I'll say, this is maybe halfway between 0 and 1. So, maybe this could be like 1/2. And I'd say maybe -1 is a good guesstimate for that. All right, we could write that solution down here if we wanted to. So 0.5, -1. All right, last question, then I turn you loose. Which of these systems has no solution? Sheila chose D as the correct answer. How did she get that? Well, obviously that means D is not the right answer. So let's take a look at A, B, and C. Which system has no solution? So think about what no solution means to us. So no solution means same slope. And what does it mean about our y-intercepts? Different y-intercepts. Right? That way I have parallel lines, but the parallel lines don't have the same y-intercept, so they're never going to meet. So I think if we just look at slope and y-intercept for each of these, I think that's all we really need to do. So let's take a look at A. So let's identify slope and y-intercept. This has a slope of, remember, you can put a 1 there, of 1x/4 or 1/4 x. So that's got a slope of 1/4. This has a y-intercept of +2. Okay, the second equation has a slope of 4 and a y-intercept of -1. So again, we're looking for same slope, different y's. I do not have the same slope. This would be a 1 solution. So A, thanks, but no thanks. B, 2/3 x minus 3. So slope of 2/3. This one has a y-intercept negative 3. Okay. Second equation, slope of 2, y-intercept of negative 3. So I've got the same y-intercept, again, different slopes. As long as I have slopes that aren't the same, I always have an answer. So B, thanks for playing, but you're not it. So I'm assuming it's C, but let's double check this just to make sure. So slope on this one is 4. Remember, there's nothing after 4x. There's nothing. That means its y-intercept is 0. This slope as well is positive 4. Y-intercept, negative 5. All right, there you go. Winner, winner. Letter C, same slope of 4, different y's, 0 and 5. So that's our one that has no solution. So how did Sheila get D? Well, it looks like if you double all of those values, right, you'd have 6, you'd have 2x and 2y. If you rearranged the second equation, if you rearranged the second equation and brought x over with y, you'd have 2y plus 2x. So I'm thinking she thought really this pair has infinite solutions, but that's not what we were after. We were after no solutions. Okay, so I think it's homework time for you guys. So 1 through 4, again, it's going to ask you a lot about systems and which ones have infinite solutions and no solutions. So use your notes, right, from previous weeks to help you answer these 4 questions, or 5 if you really want a little bit of extra credit. So I hope you guys have a great rest of the day, and I will see you on Monday. All right, have fun, everybody.